In today's video, I will teach you guys how to use Kirchhoff's law. Kirchhoff's law helps us with calculating the current and voltage in circuits. But this time, the circuit has two different voltage sources, just like this one here. As you can see here, there are two different voltage sources connected with each other with some resistors in between. But what is the current flow in this circuit? So before we go on, we check out what the current flow is, and therefore we use the current law. The current law is very easy. The current law says that if you have a connection point like this one here, all the current that arrives has to leave as well. In other words, current can't just appear or disappear out of nowhere. So in this circuit, if we add up current 1 and current 2 with each other, then we have the value of current 3. Another law that we will be using is the voltage law. The voltage law is quite similar to the current law, but this time we have to add up all voltages that are across all resistors. That value of all voltages that we add up has to be equal to the voltage of the source. So let's take this circuit as an example. We have a voltage source of 3 volts and a total resistance of 9 ohms in this circuit. The 9 ohms is split up in 4 and 5 ohms. The total current in the circuit has to be 0.33 amps, and the voltage across the 5 ohms resistor has to be 1.666 and so on volts, while the voltage across the 4 ohms resistor has to be 1.33 volts. So if we add up those voltages, we become 3 volts, which is again the voltage source. So this is the voltage law. Let's make a small exercise of this. First, I'm going to draw the circuit. Okay, I have the circuit drawn here, and we want to know how much current is flowing here, here, and there. That's the question. Let's name this one I1, this one is I2, and this one is I3. We know the direction of the current because we know the polarity of the source. So we can say I3 equals I1 plus I2, because you can see those currents add up to each other and flow here. So if we want to know how much voltage is across this resistor and this resistor, we can do this as follows. We know that current I1 only flows to resistor 1, this is resistor 2, resistor 3, like this. So 3 volts has to be equal to 5 ohms, this one, times I1, plus 4 ohms times I3. So this voltage plus this voltage equals the source, like the voltage law. So we can now write I1 differently. I1 is equal to the voltage source minus the voltage drop of this resistor. Why do we do that? Because I1 only flows to resistor 1 and not to this one. This is I3, this is a different current. So I1 only flows to R1. So we have to subtract this voltage drop. But we don't know the value of the voltage drop, so we can write it in symbols. 4 times I3, this is the voltage drop, 4 ohms, divided by, so voltage minus voltage, we want to know the current, so we have to divide it by resistance, this resistance here, 5 ohms. We can do the same with this one. So 5 volts is equal to 10 ohms times I2, this voltage, plus this voltage 4 ohms times I3. Again, we do the same for I2. I2 is equal to the voltage of the source, which is 5 volts, minus this voltage drop, 4 ohms times I3, divided by R2 or 10 ohms. Okay, we have written I1 and I2 in a different way, so we can fill this in here. I3 is equal to 3 volts minus 4 ohms times I3 divided by 5 plus 5 volts minus 4 ohms times I3 divided by 10. I3 is equal to, we can just multiply this one, so this will add up together more easily. 6 volts minus 8 ohms times I3 divided by 10 plus, and this one stays the same, 4 ohms divided by 10, like this. So now this can add up more easily. We see 6 volts and 5 volts, so we have 11 volts minus 12 times I3 divided by 10. We can replace this 10 to the other side, so we have 10 times I3 is equal to 11 volts minus 12 times I3. I3. I'm going to continue on this side here. So we can move this part to there. What we have to do is change the minus to a plus. So we have 22 times I3 is equal to 11 volts. We want to know I3. So I3 is equal to those 11 volts divided by 22 is equal to half of an amp. So we know here in this direction there is a half an amp flowing. So we just can use the law of ohms. If you want to know the voltage across this resistor, we have to multiply the current times the resistance. So voltage is equal to current times resistance is equal to a half times 4 is equal to 2 volts. So we know there is 2 volts across this resistor. Now if we look in the upper circuit, 2 volts, and we use the voltage law, 2 volts plus something we don't know is equal to 3 volts. So this voltage has to be 1 volt because we have 2 volts plus something we don't know is 3 volts. So we have the formula 3 is equal to 2 plus x. What is x? X is 1. Yeah, pretty obvious. So we know there's 1 volt over here. And now for the other one, again, there's 2 volts subtracted by the 5. So here is 3 volts remaining. If you want to know the current of I1, just again the law of ohms. We have 1 volt over 5 ohms. 1 volt divided by 5 ohms is equal to 0.2 amps. Now we have 2 ways to calculate I2. We can use this formula, which says I2 is equal to I3 minus I1. Is a half minus 0.2 is equal to 0.3 amps. Or we can use again the same method as we used here. The voltage is equal to current times resistance is equal to so I2 is equal to that 3 volts divided by 10 ohms. Is equal to 3 divided by 10, just to be sure, 0.3 amps. And as you can see, those are the same, and that's how you use the law of Kirchhoff.